Hello and welcome again. So, today we'll be discussing a problem in complex analysis, and this was asked in GATE 2017. Okay. For previous and many other problems, you can visit this link, which is given in the description of this video. So, the problem is, let's see, be a simple, positively oriented circle of radius 2 centered at the origin in the complex plane. Then we want to evaluate this integral. So what is positively oriented circle? So it means that the circle is oriented counterclockwise. Okay. And we want to find out what is the value of this integral. So I recommend you to try for a solution and then we will proceed for the solution. Okay. So I hope you have a solution. So I'll be using this whenever we have the complex integration. This theorem, which is called Cauchy integral theorem, is one of the main ingredient in complex integration. It says that if gamma is a simple closed curve and f is an analytic function in the interior of gamma, then this integral vanishes. That means if this is my gamma and this is the interior of gamma where f is analytic, then this integral is 0. Okay. So now you note that we have z e to the power 1 by z plus tan z by 2 plus 1 by z minus 1 times z minus 2. And this I can write, and of course there was some constant outside. This I can write integral this plus integral this plus integral this. So let us see each integral step by step. So the first integral is z e to the power 1 by z dz. So this at 0, it is not analytic and therefore we cannot use the Cauchy integral theorem. So let us see what is the Taylor series expansion of e to the power z. So it's 1 plus z square by 2 plus z cube by 3 factorial and so on. And therefore if I write down e to the power 1 by z Taylor series expansion, I'll be having 1 plus 1 by z plus 1 by 2 z square plus 1 by 3 factorial z cube and so on. And multiplied with z will give me z plus 1 plus 1 by 2z plus 1 by 6z square and so on. And this is equals to, so if you have f z and if z naught is an isolated singularity, then we can write the Lorentz series of f near z naught. So it says that it is an z minus z naught to the power n, where n equals to minus infinity to infinity. And this a minus 1 is called the residue of f at z naught. And integral fz dz is equals to, so if gamma and if z naught is contained in gamma, then this is equals to 2 pi I times residue. Okay. So here, what is the coefficient of? And see, 0, z equals to 0 is inside C and it is an isolated singularity. And hence this is nothing but 2 pi I times residue of fz at z equals to 0. Okay, this is residue. So, and what is the residue? It's a coefficient of 1 by z and this is 1 by 2. And therefore, this integral is 1 by 2 times 2 pi I, that is equals to pi I. So, this is equals to pi I. Okay, so the first integral is done. Let us talk about the second one. So, tan z by 2. Okay, so what is tan z? It's a sin z by cosine z. So, tan z by 2 is sin z by 2 by cosine z by 2. And this is analytic and this is analytic, and therefore this will be analytic if this is non-zero. So cosine z equals to 0 if and only if z equals to the odd multiple of pi by 2. Okay, and therefore cosine z by 2 equals to 0 if and only if it's a, so of course we are taking 2n plus 1 pi and then n equals to, n is from 0 1 2. Okay, that's why I have taken plus minus. Okay, nice. So, and what was the circle? Circle is of radius 2. And this vanishes from pi, 3 pi, or minus pi, minus 3 pi, which is outside of this circle. Therefore, this is an analytic function inside C, and hence the integral is 0. Okay. Now the third one is 1 by z minus 1 and times 1 by z minus 2. So this, using the partial fraction, we can write 1 by z minus 2 minus 1 by z minus 1. Okay, because what is this? This is z minus 1 minus z plus 2 divided by z minus 1 times z minus 2. And this is cancelled, and it's 1 by z minus 1 times z minus 2. And now we have this very important result which says that if you want to integrate dz by z minus a over the circle z equals to r, mod z equals to r, then it's 0 or 2 pi I depending on whether a is outside or a is inside. Okay, so therefore since this is equals to this, and which is, and 2, see the first one varies at z equals to 2, so it is on the boundary, and hence this is equals to 0, and this is equals to minus 2 pi I, and hence this is equals to minus 2 pi I. Why minus? Because there is already a minus sign. Okay, so therefore this is equals to 2 by pi I, this is pi I, 0 and minus 2 pi, and which is equals to minus 2, and therefore the value of this integral is minus 2. Thank you for your time and patience. We'll discuss again a problem on abstract algebra tomorrow. Goodbye, take care.